Okay, Suzanne and Karina love to go on long runs. Every Saturday they like to go on a run on Foothill Boulevard. The run takes about 4 hours. The below piecewise function estimates the distance they travel for each hour of their run. Graph and answer the following questions. Okay, so we're going to use this piecewise function to graph it, okay, and then figure out what it means. So the first thing we're going to know is what we care about when we run, just so you know, because I run, is how fast we're going, right? Okay. Speed. How is that related to math and an equation? Miles per hour is what the speed would be in, okay? But in this equation, and in math in general, how is your speed? What do we call another word for your rate at which you're going? What's another word for rate in math? Slope. The slope, right? Okay, yeah, you are. Okay, slope is rate of change, right? Well, we talked about it. So we need to identify in this equation our slope, or the rate at which we're going. Okay? So this is a little bit different type of an equation than we're used to looking at. Okay? But really this is all this is. So this equation is just the point slope equation. Okay, it is the y minus the y1 equals m times x minus x1. They just got the y by itself, so they added the y1 to both sides. And then they ended up with this. So this equation is what it is. It's y equals m times x minus x1 plus y1. Okay. So in this is the x1, this is the y1, this is the x1, this is the y1. So what I want you to do right now is go and look at this equation and find out what their speed is for each hour. Just go circle the numbers that are the speed for each of those equations. Because that's what they... Okay, so once again, we said that rate of change, or the rate at which they're running, is the same as the slope. So all I'm asking you really to do is just identify the slope. Okay? So in that first one, Evan, what is the slope of this first equation? 7. So that means she is running 7 miles in an hour. Okay? The next one. How fast is she going? 6 miles per hour. Then 4 miles per hour. And then 5 miles in that hour. Okay? That's all that means. Okay, so we're going to graph those lines. Let's start with the first one. The first one is just y equals 7x. Okay. Since we're talking about running, when I'm starting to run, what's the time when I start? 0, okay? Okay, this should be time, and it's in hours. and this is going to be distance in miles. Okay, so she's going to start at 0 minutes and 0 miles. Then her rate of change is 7 miles in 1 hour. So from here she's going to go up 1, 2, 3, 4, 5, 6, 7, and over 1. Okay, so from 0 to 1, that's how fast they're traveling. So do I need to continue on? Okay, it stops at 1 hour. So now after 1 hour, she's going to change her rate of her speed. They're not going to be going the same speed. Okay, so we need to change our equation. So now we're going to go with the next equation. And that is number 2. That's f of x equals 6 times x minus 1 plus 7. Okay, she's starting after 1 hour. So we're going to start here for this one. Okay. This is where we begin because that's our ordered pair at 1 and 7. Change the sign in the parentheses when we pull it out. It's just like the twilight zone, just like when we had quadratics. In parentheses is a twilight zone, change the sign. Okay. The y1 is 7. And that's what this point should be. So we're already at 7, 1, so that's where we're going to start. And then we have our slope, which again is 6 miles for every hour. So from here we're going to go up 6. 1, 2, 3, 4, 5, 6, and over 1. Let me connect my dots. So this one was here. And this one was here. Okay, our third equation now is f of x equals the 4x, 4 times the quantity of x minus 2 plus 13. Okay, my point is 2 and 13. We change that sign to a positive 2, and then 13, and that's where I'm going to begin. And this also tells you I'm starting at 2 for x, my second hour. Anyone confused? Need some help. Okay, so then we're going to go 2 and 13, which is where I already have that point. And I'm going to use my slope again. Now I'm doing 4 miles that hour. So we're going to go up 1, 2, 3, 4, and over 1. And that should be my line. Okay, the last one. If f of x, this is number 4, equals the 5 times x minus 3 plus 17. Okay, I'm starting at hour 3. Starting at hour 3. And at 3 hours, I'm at 17 miles. And now I have my rate of 5 miles in 1 hour. So we're going to go up 1, 2, 3, 4, 5, and over 1. Any questions over that? Okay, now we're going to use that graph to answer those questions. Okay, so I want everybody to answer these questions in your pairs. When I ask you for what part of the run did they go the fastest, tell me the hours. Between what hours did they run the fastest? Hold on one second. Not the first half. The first hour. They ran the fastest the first hour. Okay. Jasmine, when was the slowest? Where did she go? Oh, she. I know. Donovan, when did she run the slowest? Or they ran the slowest? Okay, very good. They ran the slowest the third hour. From 3 to 4. No, wait, not from 3 to 4, but from 2 to 4, right? So 2 to 4 hours. Sorry, it's not 2 to 4, 2 to 3 hours. Oh my goodness. Okay. Any questions over that? Who understands that? Okay, what is the domain of the function? Brandon, what's the domain of the function, of the whole function? B? Mm-hmm. Less than or equal to? Very good. The domain was from 0 to 4. Okay, they didn't run negative hours, and they didn't run any more than 4 hours. They stopped running at 4 hours. They were done. Done too. Okay? Find f of 2 and explain what this means based on the scenario. Jacob. Yep. What is f of 2? Okay, so what does this mean? Okay, we're going to look at the graph, and we're going to look at 2 for x, right? F of 2 means x is 2. What's the y value? It's 13. So f of 2 equals 13. Okay, but what does that mean? Yeah? Very good. They ran 13 miles in 2 hours. Okay, that's all that says. Okay? Now, how far do they run after 3 hours? And then we want to use function notation. So let's start with how far do they run? Yasmin, how far do they run? At 3 hours, how much did they run? 17. Okay, and they want function notation, so that's just f of 3 equals 17. This is what we call function notation. Function notation. That's all this is. Okay. Any questions over it? And in total, class, how many miles did they run? 22 miles. Now, is that reasonable? Not that you want to run this, but could they run 22 miles in 4 hours? Okay? Would that be a fast pace or a slow pace? Medium? No. Well, I guess if you did the average of it, what did you do, 22 over 4? So that's about 5 point something miles an hour. 5.5, yeah. 5.5 miles per hour is their average, what they averaged. Okay? Can you guys run 5.5 miles in an hour? You probably could. You probably could if you actually wanted to run for an hour. Okay? Okay, it's about a 10, we did this in the second period. It's about almost an 11-minute mile. Okay? So you basically are running a mile in 11 minutes, about. Actually, a little bit under 11 minutes. Okay? So we'll just say like 10:50. Okay? So it's doable. But do you want to run for 4 hours? That's the key. Okay? Okay, we're going to skip the next one. Oh, it's a really good problem, but I want to make sure you guys can do all this other stuff, because it's very similar to the one we just did. Thank you. Okay, so we skip the back and we go to the next page. Everyone has this page. Okay. We're going to talk now about non-continuous piecewise functions. Okay, what we've been doing so far, all of our lines are connected. Okay, there's no spaces in between them. So now we're going to graph piecewise functions that will have spaces. They won't all connect and make one kind of shape. They'll be separated. Okay, and we get to do quadratics again. Yeah. Because you learn quadratics, and so now everybody knows how to graph a parabola. Okay? And you need to continue to know how to graph a parabola from now on. So what? You will use it in this class. That's real life. Okay? So right here, this is a quadratic function. This one is linear. This one here is also linear. Okay, please tell the person sitting next to you how you know if an equation is linear versus quadratic. Talk to each other. Okay, so how many of this is quadratic and then this one is linear? Can someone raise their hand and tell me? Dustin.
If it's linear, it's not squared.
Yes. And so if it's quadratic, it is squared. If you have a square, x squared or x plus 2 squared or 5x plus 7 squared, something squared, it's going to be quadratic. Okay? If it's not squared, it's linear. Okay? So that's the easy way to tell, is just look for that exponent of 2. So, we're not there yet. We will not see that yet. Okay? Next year. You'll get to cubes and no. Hyperbolas deal with x squared and y squared. Yes. so let's graph this. Okay, our first equation is quadratic, so vertex form of a quadratic equation is a times the quantity of x minus h, the whole thing squared, plus k. Remember, our vertex is h, k. And our a value is our stretch and our shrink. Remember, quadratics don't rise at a constant rate. They rise at a patterned rate. And it's a, then 3a, then 5a. So it's the 1, 3, 5 pattern. So when we look at this, we want to find the vertex. HK, HK. Remember, inside the parentheses is the twilight zone, so we actually change the sign. It's not positive 2, it's negative 2. And the 1 stays positive. Outside the parentheses, it stays the same. So we're going to graph negative 2 and 1, and that's my vertex. Any questions over that? Okay, now our A value. Our A value is the number in front of the parentheses. Very good, it is 1. There's nothing right there, so that's the number 1. So it's 1, and then 3 times 1, and this is always over 1, and then 5 times 1 over 1. So then we go over 1 and up 1, up 1 and over 1, up 1 and over 1. Then from here we're going to go 3 times 1 is 3, so up 3, 1, 2, 3 and over 1. And then up 1, 2, 3 and over 1. Okay, don't draw it yet because we have to worry about the domain. Okay, this parabola is not necessarily going to look like this because it has a beginning and an end. Okay. So now we look at the domain. And the domain is x has to be less than negative 1. So we look at the x values. And so our graph should start right here. Okay. So we don't need that point right there, because that's at x equals 0. Okay. We then worry about, can this equal? Can it equal negative 1? Is negative 1 less than negative 1? No. So it cannot equal negative 1. It's going to get close to negative 1. So that's when we have to use our open circle. It cannot equal negative 1. Therefore, that's what this little symbol means. It has an open circle. You gotta remember back to integrated 1, where we graphed on number lines, and we put open and closed circles, and we shaded where numbers were greater or where numbers were less. Okay, and that's where this comes from. Okay, then can it go to negative 5? Is negative 5 less than negative 1? Yeah, it is. Can it go to negative 6? Negative 7? Okay, it can go negative forever, so we can just draw this part of it. And it has an arrow that tells it it's going on forever. And try and hit that dot. I didn't make it very well. Let's try it again. There we go. That's a little bit better. It stops at negative 1 for x and 2 for y. We don't really care about the y value, we care about the x value. Any questions over that? Okay, next equation. The next one is linear. Okay, so that's just y equals mx plus b. So we need to find the slope. So we look here. In class, what is the slope? 1. Right here, 1 over 1. And then we want the y-intercept. Diane, what is the y-intercept here? 2. Okay, so we're going to begin at 2 on the y-axis. And then just move up 1 over 1. Up 1 over 1. Up 1 over 1. Okay. I'm not going to draw the line yet because we need the domain. Is negative 1 is less than or equal to x is less than 2. So where should this line start at? At negative 1. Okay, so I need this line to extend to negative 1 for x, so it's just going to go here. Because if I extend that line, that's where it's going to go, right? Can it equal negative 1? Yes, so it's a closed circle. Now this one has an end point. So it's in between. X is in between negative 1 and 2. So where is this going to stop? At 2. Okay? So I have to erase that point that's at 3 because it doesn't go that far. And then this cannot equal the 2. So this is a closed circle. Not closed, sorry, an open circle, what am I saying? It cannot equal it, so it's open. And this is your endpoint for this function. So this line is only going to go from negative 1 to 2 and stop. And it should have an open circle right here, like this. And so now this is my line. Like that. And notice they're not connected. They don't have to be connected necessarily. Any questions over that? We're all good? Okay, the last one. Last equation. I'm going to move it up here. It too is the y equals mx plus b. So we need our slope and our y-intercept. John, what's my slope? Negative 1/2. Okay, and John, do you know the y-intercept? There is one, 0. It crosses the y-axis as 0 because it's like plus 0 here, right? It's not written in because we assume it's there. So it's right there, and then I'm going to go, this is negative, so I'm going to go down 1, and then to the right 2. Down 1, right 2. Down 1, right 2. And then we need to see, okay, the domain. Is x is greater than or equal to 2. So this is my starting point at 2. Okay, so I don't want in this point here. I want to start at 2 on the x. So here's my x. It needs to start right here. Can it equal the 2? Yeah, so this is a closed circle. So they can equal it. Okay. And does it have an end? Will it stop at any point? Where is it going to stop at? It's starting at 2. Where's it going to stop? I just want numbers greater. Okay? So this is going to continue on forever. This way. So I put a little arrow on it to know it's going to keep going that way forever. Any questions over that? We're all good? Okay, let's make sure we know how to do this. So I want you guys to get your homework out. And I want you to do number 7 in your homework. Okay, everyone's working together on number 7 in their homework. Okay, so number 7, we're going to start with the linear. Okay, our slope is 1/2, and our y-intercept is 3. So we begin at 3 on the y-axis, and then move down 1 and over 2. Down 1 and over 2. Okay, that's probably what most of us did. Okay? Then, we need to know the domain is between -4 and 0. Okay? So my line should begin here and end here. And currently it's beginning there. So I need to extend this line this way. And remember it's a line, so it's got to go this way. So that means I have to do the slope of 1 over -2. Just move the negative to the bottom. So we're going to go up 1 and then to the left 2. Up 1 and to the left 2. Now I begin at 4 and I can end at 0 for x. That means I can erase all this. Any questions over that? Yes. Yes, we're going to get there. Now we're going to look back at the domain. Thank you. Okay. The -4 is a less than or equal to. So that's going to be a closed circle right here, because it can equal that number. But if you look at the value for x at 0, it can't equal 0. So this number here, or on this dot, needs to be an open circle. This should be open circle. And then this would be my line. Any questions over that? Good job. Now this second one is a parabola. Hold on 1 second. Oh my goodness. The second one is a parabola. So it has a vertex at 1 and -2. Remember that inside the parentheses you change that sign? So then -1 becomes a positive. So we're going to graph that here at 1 and then -2. Then here our a value is 2 over 1. Then 3 times 2 over 1. And then 5 times 2 over 1. Because our a value is 2 right there. So here we're going to go up 1, 2, and over 1. Up 1, 2, and over 1. Then up 6, 1, 2, 3, 4, 5, 6, and over 1. Up 6, and over 1. Make sure if you graph that parabola that your parabola has up 2 and over 1. Has the a value 2. Then we also need to talk about the domain here. 0 and 3. It begins at 0, so I don't need that dot. And then it ends at 3, and so here's the 3. So it ends here. Okay? At the 0, it can equal it, so I can close it in. At the 3, it cannot equal it, so it's an open circle. So this is my parabola. Any questions over that? Okay, so how do we do? Okay? Okay, do 6 now. Make sure we can do that. Okay, so now we're going to be given the graph and we want to come up with the equation based on the graph. This is a little easier. Okay? People are struggling more with the graphing than they are with writing the equations. So, you shouldn't be you should be okay with this. Okay, so for the number 1, okay, so for number 1, it's a line. So we're looking for the equation y equals mx plus d, because it's linear. It looks like a line, right? Okay, so we need our slope. So it goes up and over. Okay, so up 2 and over 1 is the slope of 2. We also then want to find the y-intercept. Does it cross the y-axis? It doesn't right now, but we could probably tell where it would, right? If we went up 2 and over 1. If we continue this on, it would cross at 1. So that's the y-intercept. But it got erased, remember? Okay. So you can see the y-intercept by extending the line. Find that. Okay, if not, you're going to have to use the point slope formula. The y minus the y1 equals m times x minus x1, using that starting point and the slope. So this is easier. So the equation of this line is y equals 2x plus 1. Then we just need the domain. Okay, so here's my beginning part. You want to know where it starts for x and where it ends for x. So it starts at -4 and it ends at -1. Manual. At -4, can it equal -4? Yes, it's a closed-in circle, so it can equal that. So you have to put an equal sign underneath that. So it's a closed circle. Okay. Then we look at the -1. At the -1 class, can that equal it? No, it cannot, because it's an open circle. So you don't put a line underneath it. You just leave it as a less than sign. This one right here can't equal -1. So that's how I know it's the less than sign. Any questions? Okay, the next part of this equation, or this graph, is quadratic. So we have to use the y equals a times x minus h, the whole thing squared, plus k. Okay, because this is quadratic. Can someone raise their hand and tell me how I know this is quadratic? Yes, Marissa? Well, I know it's squared here, but how by looking at the graph would I know? Yeah? It's a parabola and not a line. Parabolas are quadratic. They have a squared. Okay, just so you know. Okay, so now in this one we need the vertex and we need the a value. So everybody look at this and try to come up with a vertex for me.
Is this like the 1, 2?
So it's from this circle to this point.
Okay.
Okay, Kyle, what'd you get for the vertex? Very good. 0 for x and -3. It's right here. That's the lowest point of the parabola. Then the a value is just up 1 and over 1. The a value is 1. Any questions over that? So you're going to plug it back into your equation. You're going to get y equals a value of 1 times x minus 0, the whole thing squared, plus, not k, plus a -3, so that would be -3. Okay, it won't be left like this. When you see this equation, you'll actually do x minus 0 is 0, and 0 squared is x squared minus 3. Then we need a domain. Okay, Marissa, what is this values? Less than. 2. Okay, so it's in between -2 for x and +2, so from here to here. Okay, on the -2, is that equal to, can it equal the -2 class? Right here? Is that open circle mean I can equal it? No, I cannot equal it, so don't put a line underneath it, cannot equal. Okay, here, on the 2, can I equal that 2? Yes, it is a closed circle, so I can equal it. Any questions over that? Brandon, are you with me? Okay, good, write it down. Okay, everyone come up with the third equation. Okay, if you need some more space, we're not going to do this problem, you can write this down. You can write it down here. This right here is not -2 for x, it's -1 for x. So this should be a -1, not the -2. It still can't equal -1, but it's less than x is less than or equal to 2. Sorry about that. Okay, so let's see how we did. Anthony, for this one, what did you find your slope to be for this line? Shh, I'm talking to Anthony. I'm sorry? Okay, it went down, so what should that actually be? -1. So your m should be -1. Lauren, where would it cross the y-axis if it got extended? At 3. So the b value, your y-intercept would be 3. Okay, so your equation should be y equals -x plus 3. Then we need the beginning and the end, the domain. So it starts here and it ends here. So it starts at 2 and ends at 6. Okay, so is there an open or closed circle here at 2? Closed, so it can equal. Okay, but I'm going to teach you a new rule. Okay? Yeah, super exciting. Since this one these repeat. This equation has a domain that ends at 2, and this one begins at 2. You cannot have them both have an equal to. They can't both be equal to. Now, I don't care if this one's equal to and this one's only less than, or other way around, this one's equal to and this is less than. That's okay. But they can't both be equal to, because then this would not technically be a function. Okay? So since this 2 has it, and it's only when these numbers match. Since this is 2 and this is 2. If this one was 2 and this is 3, we didn't have to worry about this. Okay? But since they're both equal to and they fall on that point, they overlap there, and they're colored in, then only one can be the equal to. It's going to stay like that. And then this 6, it's an open circle, so it doesn't need a line, so we're done. Okay, let's write the whole function, the whole equation, should look like this now. The piecewise function looks like this. We do that weird bracket. We have 2x plus 1, semicolon, our domain of negative 4 is less than or equal to x is less than negative 1. We do the next equation, the x squared minus 3 with the domain. Remember, we changed that negative 1 is less than x is less than or equal to 2. And then we have that last one, y equals negative, I don't need y equals, I already have that. The negative x plus 3, and the domain was 2 is less than x is less than 6. And that's my piecewise function. Any questions? Okay, your homework is the last 2 pages of your packet. Numbers 1 through 12. It's numbered. Okay, you're graphing. Yeah, real quick, let's look at the first problems, because some people are getting confused by that. Let's look at these problems really fast, you guys. I'll try to. Okay, I'm doing the homework for you. Pay attention, because you're going to be confused if you don't pay attention right now. They want you to evaluate each piecewise function for x equaling negative 8 and x equaling 5. Now, the difficult part of this is figuring out which equation you're going to plug it into. You need to figure out which of these falls into which of these domains. Okay? So, is negative 8 less than 0? Or is negative 8 greater than or equal to 0? Okay, it's less than, it's this one. So we're going to use this equation for it. Does that make sense? So we just then do f of negative 8 equals this equation, the 2 times the negative 8. So f of negative 8 equals negative 16. Okay, that's it. Then we look at this one. Now they want us to worry about 5. X equals 5. So is 5 less than 0, or is 5 greater than or equal to 0? Okay? It's not less than 0, it is greater than or equal to 0. So we're going to use this equation. Okay. So we're going to do f of 5 equals, there's no x to plug this in, so it's just equal to that number, equal to 0. And I don't have to do any math there. Okay? So you do the same thing with this one. You're going to find out where the negative 8 goes for this, and where the 5 goes for these. Plug in the numbers to see which one it works with. Does that make sense? Okay.